I'm Melissa.
I'm Jam.
And I'm a doctor.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life. So if you have never listened to our podcast before or only have joined us recently, Melissa is really very recently actually a doctor.
I'm a PhD doctor.
PhD doctor.
That's right.
Just got her PhD finished up between right now, you hearing us, and the previous episode that we recorded.
That's true. Yeah.
And so that's real. She's a doctor, a PhD in organic chemistry education.
Just chemistry education.
Sorry,
but
man.
we'll talk about that.
Okay, chemistry education, and I'm really not. And so when we talk about chemistry stuff, Melissa actually knows what she's talking about.
Yes.
And she's actually teaching me, who does not know it.
That's true. And today is actually a big celebration of that accomplishment because I'm going to talk about one of my favorite things, which is my work.
Nice.
A lot of our listeners have asked me about this for a long time, but you actually kind of have to be careful about sharing research that's not published yet. You just have, it's better to wait until it's published.
Seems wise.
Yes. And so since I've given a public defense, I am able to share a little bit about my work. But I'm not just going to share about my work. I'm also going to share about the whole field of chemistry education research.
Nice, nice.
And one of my jokes that I tell people, and the reason that this title is Why Do People Hate Organic Chemistry, is that's kind of what my research is about, is do people hate organic chemistry and why do they hate it?
Mm-hmm.
That's really and truly kind of where my research started and something I'm really passionate about. And I've gotten a lot of fun student responses based on that. So we'll talk about my research some at the end, but I want to talk about what my actual field is first because not very many people have heard about it because it's relatively new.
Right, right. And you can probably tell this is already sounding like it's going to be a slightly different episode than normal, but it's going to be super cool. So stick around, please.
Yeah. So there's not like a traditional chemistry lesson, but there is something that I think most chemists will be able to get from this, and people who are interested in learning about science and the way research is done, that those people would be able to get out of it. And actually, a lot of our listeners have pretty consistently asked me what research you can do outside of the lab or how you can be a chemist and not be in the lab. And this is another way to do that, where you can actually explore chemistry and do chemistry research not using actual chemicals.
And I think there's a lot that's interesting here. I don't know everything that Melissa's going to share, but when I was watching her defense and her presentation and stuff, there was so much that just me, regular person, not a chemist, very interesting to hear, to learn about in this chemistry education field.
Yes.
And some of the data specifically Melissa found and some of the things that she asked people about and stuff. So I think if you're like me, and then you'll be able to understand it, get it, and enjoy it, just like the whole goal of most of our episodes.
Yes. So. And actually, this one's a little bit different because Jam did come to my defense as a civilian. And some of our listeners did too. But I'm going to share a little bit more about the field of chemistry education research and what that is. So even if you came to my defense, you'll get more information out of this.
Nice, nice.
So a lot of people I have noticed think chemistry education research is essentially getting you ready to be a good educator. And I do think it's important for educators to be up to date on the most current research, but it's actually not quite about that. Many of us are educators, and many of us care a lot about being good educators. And I think doing research in education prepares you to be a better educator in some ways, but it actually is focused on the research. So I'm not trying to learn about how to be the best educator I could be necessarily. I think I get some of that out of it. But what I do in my research is I try to understand how students are learning chemistry. So how an understanding of chemistry, a baseline understanding of chemistry develops, and then even further, how an expertise is developed in that field. That's really what chemistry education research is about. We are trying to learn via research. We are a research-based field, not a teaching-based field.
Got it.
And we, as most of us also are educators, do apply a lot of that research. But it's technically, the expertise is not in being an excellent teacher. The expertise is being an excellent researcher. Okay. So most people have heard of, you mentioned earlier, organic chemistry. There's also analytical chemistry and inorganic and physical chemistry. I would say these are the core 4 traditional divisions of chemistry. Most departments have people doing research in those 4 areas.
Okay.
However, there are newer divisions which are being developed over time. So one example is some departments now have a polymer chemistry division, and we've talked a lot about polymers. And actually, another kind of new emerging division is computational chemistry. This is really cool. I have a friend who I follow on Twitter named Emmett. He also does computational chemistry, but a lot of times computational chemists use supercomputers to predict the behavior of molecules. I think it's very amazing. It's really beautiful and complicated. And we talked about computational chemistry on the lobster episode.
Right.
Very briefly. So that's an emerging division. And then chemistry education research is also an emerging division.
Right. Okay.
So these are groups within a department that are focused on doing this specific type of research. So many have organic, many have analytical, and now many also have things like computational and chemistry education. These are within those divisions. So they're all research-focused groups.
Okay.
So that's what chemistry education research is. So my PhD is in chemistry. So on my degree, it says PhD or Doctor of Philosophy or whatever, chemistry. And then my concentration is chemistry education research.
Okay.
And in that same way, my master's degree was in chemistry, but my concentration was organic. So I have a master's level expertise in organic chemistry and a PhD level expertise in chemistry education.
Got it.
But they're both under the branch of chemistry.
Yeah.
So chemistry education research, a lot of times we'll call it CER, is actually a type of education research that's under a bigger umbrella called discipline-based education research.
Okay.
So education research has existed for a really long time, and that's just an approach to how people learn, how they have learning processes, to education, to how thinking works, how people understand education research, and understanding how people learn and think has gone on for a long time. But discipline-based education research has sort of become a new division of that. And I really like this definition in a book by the National Research Council that defines discipline-based education research as an emerging interdisciplinary research enterprise that combines the expertise of scientists and engineers with methods and theories that explain learning. And then it goes on to say, this investigates learning and teaching in a discipline from a perspective that reflects the discipline's priorities, worldview, knowledge, and practice.
Got it.
So essentially, we're researching how people learn this specific field from the inside because we already have that expertise of our own.
Right.
So chemistry education research is one of those where we are chemists who are learning how other people learn and develop an expertise in chemistry.
Got it.
But we have already developed this expertise or understanding ourselves, so we know what we're looking for in them, if that makes sense.
Totally. I mean, it'd be so hard for somebody who hasn't been in it, who's not on the inside of that, to really even know what to research, what the current problems are, what the goal would be, what would be a better way to do it. All that stuff would be so hard for anyone to just be like, I'm just a generic researcher. Let me go over there and help solve this problem that I don't know anything about the inside of.
Definitely. And education researchers can do a lot of and have done a lot of good work. I remember reading a paper, because I did take some education research classes too, and I read a paper that interviewed Black women who had dropped out of engineering and talked to them about why. And so that wasn't actually a discipline-based researcher. It wasn't an engineer who was doing the research. It was an education researcher, and they learned really excellent things, right? So it's not necessary, but there are things that chemists know that other researchers might not, like, oh, this is a common misconception. So a really good example is hydrogen bonding.
Yeah.
Hydrogen bonding, as we've talked about many times, is not a true bond.
Right.
It's a type of intermolecular force, and students often have misconceptions about that. Another one is there's a misconception that bonds break and it releases energy, and that's just not true. And so as a chemist, we know this, and we can look for this consistent misconception.
Yeah.
So that's what the field is. And in some ways, it kind of makes things difficult because that means, if you haven't picked up on this already, but I have to have an expertise in chemistry and in education research.
Yeah, dang. Double duty.
Double duty. So I actually had to take like twice the number of courses that other people did. And my situation was different. I did all of my coursework and took all of my qualifying exams and had done pretty much everything for my PhD in organic chemistry.
Right.
And then I switched over and had to kind of start over. And I took several more classes. I think I took 6 more classes in education-focused research. And usually people take 6 graduate level courses in chemistry, and that's it. So I've taken like 12.
Oh, wow.
I've done double. And I think they kind of revamped the program after I went through it. My case was kind of special, but I do think they still have to focus on developing those 2 expertise. So they do still have a requirement of chemistry courses and a requirement of education courses. And so for me, I had already done my master's. You know, I spent a lot of time in an organic chemistry lab before I changed, and I got a master's degree after that time. If you don't have a master's degree, actually, you have to do a project for most universities, not all, but to gain that master's level experience and expertise, you have to do a project in that area. So there's a new graduate student in our group. I've shouted him out before. I don't think he'd mind me saying David. And he actually is doing analytical research in another lab group for his first year and a half or so. He's developing an analytical expertise, and he'll have to take qualifying exams in an analytical setting to prove that he has this high level understanding of analytical chemistry, and he'll have to take qualifying exams in chemistry education research too.
Wow.
Yes, and that should be part of his dissertation, I think, is he'll have a chapter on that.
Okay.
So oftentimes that's expected of people who have degrees in chemistry education research, as they have to have shown an expertise in a traditional chemistry area first. And that usually is closely associated with the area they do their long-term research in, but not always.
Got it.
So I have several friends who also started out in organic chemistry and then decided that they didn't want to be in an organic chemistry lab for the rest of our lives, just like me. And their research area is now understanding aspects of organic chemistry and how students learn organic chemistry and how we can improve the course overall.
Got it.
So that's what chemistry education research is. I've experienced a lot of people, even chemists in my department, who, when I say something about chemistry education research, and there's a lot of grants you can get, actually, there's a lot of funding that supports chemistry education research, and it doesn't take a ton of money to do. You know, we were having a conversation about that, and somebody said, "You don't make a lot of money teaching." And I was like, "Oh, you don't know what chemistry education research is. Like, you thought we were talking about teaching this whole time."
Yeah.
So that was someone in my department.
Yeah.
And I realized how widespread the misconception was at that point.
I guess it's like they already start to form their thought, like chemistry education, before you even said research. They're like thinking, "Oh, okay, teaching, got it." And it's like just your mind starts to find the quickest answer.
Yes,
which it's unfortunate that is the case in your own like people that you are around all the time. That still, yeah.
And I think there's something separate, and I don't know a lot about this, called scholarship of teaching and learning, and that is learning how to be the best teacher you can be. So I think that existing simultaneously in conjunction with, like, very closely near chemistry education research, those things would feel like they're the same. And unless there's a very clear line drawn, you know, or unless there's someone that you know who can explain the difference to you, a lot of people just haven't heard about this because it's an emerging division.
Yeah.
And that's why I make a habit of always saying chemistry education research, is to try to really emphasize that we're not focusing on the education, we're focusing on the research.
Yeah.
So now I'm going to talk about what chemistry education research is.
Okay.
The nitty gritty. So I defined it for you. I told you what we care about, what our goals are, but how do you actually do it?
Yes. How do you do it?
How do you do it? Because in other chemistry research, you maybe mix things together and get new molecules. You have instruments that give you information, and you use that information to draw conclusions.
And sometimes the thing you mix together, you take a sip of it when one was looking just in case.
No, you don't do that unless it's a food chemistry experiment in your kitchen.
Okay.
Even then, maybe not.
So that would be normal chemistry.
That's normal chemistry when you sip it in your kitchen.
Yeah.
My sister got me a apron once that said, chemistry is like cooking, but you just can't lick the spoon. Nor would you want to.
Yeah, that's good. I like that.
But cooking is chemistry. So.
Yeah.
So in chemistry education research, we also have instruments.
Okay.
But they're usually different than the classic quote unquote instruments you think of being in a lab. So we don't have an NMR. We don't have these things that shine light and tell us about the molecules of makeup. Instead, the makeup of molecules. Instead, we have things like interview guides or surveys, which are instruments that give us data about the thing we're studying, which is the human brain.
Okay.
Specifically, the human brain thinking about chemistry.
Right.
And we have methods to make sure that the data they give is precise and accurate. And I like the definitions of precision and accuracy is if you hit the bullseye. And precision is if you hit the same thing over and over. So you want it to hit the bullseye and you want it to hit the bullseye over and over.
Got it.
So is our instrument getting the data we think it's getting? Is it getting the right data?
Right.
And is it getting the right data consistently?
Right.
That's what we want.
Yeah, that's really helpful. I like those definitions.
Yeah, I think those are very important. So we have to make sure our instruments, in the same way you would calibrate in any other division, and you would use a baseline or something, a standard that you know what the makeup of this is. So you're going to run your instrument through this to make sure it's good before you go in a classic chemistry lab. In our chemistry research, we do something similar with our instruments where we make sure they're doing what we think we're doing.
Got it.
And that's usually referred to as validity and reliability. Sometimes it's referred to as trustworthiness, depending on the nature of the data.
Okay. And
sometimes we have qualitative data. So that's words. So sometimes students give us words like in interviews or if you have a free response question on a survey. And sometimes we have numbers.
Mm-hmm.
And with numbers, then you have to be able to do a lot of statistical analyses. So you also have to have an expertise in that.
Yeah.
Which is harder for me.
Right.
I had to fight tooth and nail to get my statistics expertise. And I'm not even sure at this point that I would call that part quite an expertise. So for both of these word data and number data, we have ways that we analyze them that are repeatable and that are transparent and trustworthy, and we know that the analysis is sound. In the same way, if you're in an organic chemistry lab and you think you made a molecule, then you're going to get information about that molecule using instruments, and then you have all these you can get readouts from a bunch of different instruments and compare them together and say, oh, is this solid? Does this really support my evidence? Do I have all these things? So like I could use an NMR and an IR and a crystal structure, and they all point to that I've made the thing that I said I'm going to make. We have similar methods of analyzing with multiple groups or places, and then we bring them together, kind of.
Okay.
So that's how you conduct chemistry education research. And even when you're designing the project, it's founded in that original education research, right? So we have frameworks that we use to look at an area. And I feel like that's kind of vague, but another way to think of it is the way we look at an atom is sort of a framework, right?
Yes.
So we have a framework to think about how molecules are going to interact based on what we know about the atom, the framework we have about the atom.
Yeah.
So a good example of this, I think, is my boss, Molly.
Uh-huh.
She has really cool research, and she has a framework that's easy to understand, I think. So I'm going to talk about her work a little bit, and then I'll talk about mine.
Okay.
So my boss, Molly / Dr. Atkinson, that's her fancy name.
Mm-hmm.
She does research with a different instrument. It is not a interview guide or a survey, although she does also do interviews with these, but she has what's known as an eye tracker. And they use eye trackers. People use eye trackers in marketing, in sports analyses, and all kinds of things. And it literally watches your eyes, uses infrared light to shine on your eye, and then the reflection comes back down, and the computer can use the angle of the reflection to literally track what your eyes are looking at on the screen.
Wow.
It's very cool.
Yeah.
And it gives you a lot of quantitative data, a lot of number data.
Right.
So the framework that Dr. Atkinson uses to shape her research is something called representational competence. So what that means is we have a lot of different representations we use in chemistry, right?
Mm-hmm.
So we have the model of the atom.
Yes.
And you imagine that sometimes people imagine as a ball or maybe like an amorphous shape. And it's a cloud of electrons. But then sometimes we write it down on a piece of paper like just H or just Na.
Oh, yeah.
Or just Cl. So both of those are representations. If I can think of a hydrogen atom and I can think of a hydrogen on a piece of paper, and then I think of sometimes organic chemists will draw just lines, and that indicates a carbon surrounded by hydrogens. And we actually have what we call ball stick physical models that have balls and bonds that we like stick together, right?
Yeah.
All these are different representations of the same molecule that you can have or the same atom that you can have.
Yeah.
So representational competence is how well your ability to switch back and forth between understanding these different representations of a molecule.
Got it. As a learner.
As
basically.
a learner or as an expert, right? So experts can do it really quickly, easily. They have this ability to think about, I look at a cup of water. I know that's water molecules moving around. There's probably salt in there. And I can think of that as the water sitting in front of me. I can also think of it as the ball and stick models floating around in there. I can also think of how I would write H2O and Na plus and Cl minus, all of that on a paper at once. Like all those kind of happen in our brain at the same time as experts, but students don't have that.
Right.
And so how do students go from what we teach them very beginning, they don't even know what an atom is, all the way to experts who can use everything interchangeably.
Yeah.
So that's a good overview of the type of work Molly does. And I love the eye tracker. One of my favorite things that demonstrates how it works is she'll put up this picture that they use in marketing of a baby diaper box. And it's like there's two options. And one is a baby looking at the viewer next to a diaper box. And they track people's eyes. And of course, everybody looked at the baby because its face is so cute.
Yeah.
And it was like, oh my gosh, it's a baby, right?
Yeah.
And we love babies. And nobody really looked at the diaper. And then they have one where the baby is looking at the diaper name brand. And in that one, the eye tracker showed that they were looking primarily at the eyes.
Got it.
Or at the, they were looking primarily where the baby's eyes were looking. So at the name brand of the diaper, which is what marketers want, right?
Yes.
So that's a good way that you can think about eye tracking, gives you insight into what people are looking about, helping you know what they're thinking about.
Yeah.
So the first one, they were thinking about what a cute baby. The second one, they're thinking about the name brand, what the baby's looking at.
Yeah.
So we do similar things where in Dr. Atkinson's group, they're looking at, okay, where is the student's eyes on this computer, whatever representation we're showing them, and what does that tell us about how they're processing this information and what expertise they have?
Yeah.
There's a really interesting study that already came out by, I believe, Dr. Megan Connor, who looked at students interpreting this specific type of spectra. And they looked at students and experts. And students were exhibiting this searching behavior where they were kind of panickedly looking all around and trying to figure out what they even should be looking at. And experts looked at very few points. They looked at the molecule and they looked at the spectra, and that was it.
Wow.
And so you can kind of look then, okay, what happens all these steps in between when they get to this step, right? If you can follow someone along, or if you can look at different people along the process of developing an expertise.
Yeah.
So that's eye tracking. So that instrument is the eye tracker itself. And then Dr. Atkinson's group also does interviews. So that's another instrument that they use to get data, and that's qualitative data. So they have both quantitative and qualitative.
Okay.
And the framework that they use is that representational competence. So they design their projects around trying to understand how students are looking at these different representations, basically. So there's a framework through which they can look at the world.
Okay.
A framework through which they can build up their project because there's a baseline understanding of how we interpret molecules, basically.
Yeah.
So that's how you kind of design a chemistry education research project, or what it could kind of look like.
Okay.
But there are so many different areas. So you can do chemistry education research in general chemistry, organic chemistry, analytical chemistry, inorganic chemistry, polymer, whatever thing that people can learn chemistry in, you can do research in that area.
Yeah.
And there's also what they call different domains. So there is this theory called human constructivism that essentially states that when people are learning, we want to target their feelings, their thoughts, and their actions. And all those things have to come together to create this meaningful learning experience where we can actually have students connect new information to existing things in their mind. So learning is actually happening, and it's not just rote memorizing. It's what it sounds like. It's meaningful learning. It's connections that actually have some kind of significance. And there's a deeper understanding than just memorizing things.
Yeah.
Okay, so some people look at the cognitive side. So what students think about when they're trying to solve an organic chemistry problem, for example, or when they're trying to do a multimole conversion or something like that. Some people look at how students' feelings impact them. So one of my favorite studies in this is an organic chemistry study. Dr. Jeff Raker and Rebecca Gibbons, they both, also Dr. Rebecca Gibbons, doctors Jeff Raker and Rebecca Gibbons, researched how students' self-belief, so how they think they're going to be able to do, impacts their end of semester grades. And some people have looked at how students' motivation can impact that. And what is interesting to me is there are a few studies that look at how motivation impacts organic chemistry grades, and they found instead that self-belief was a bigger correlation to end of semester grades than motivation. They set out to learn about motivation, and what they learned instead was whether or not the students are motivated seems to play a less role than their self-belief.
Wow.
Yeah.
Dang. That's crazy.
I know.
Yeah.
So that tells me that it really matters that we tap into our students' feelings. And something that Dr. Raker and Dr. Gibbons love to say is learning is an emotional experience.
Yeah.
And if you've ever sat in a classroom and been really mad that you couldn't understand something, or been really excited when you did understand something, you know that already.
Yeah. Oh, yeah. 100%.
And this idea of self-belief is if students believe they're capable, that can impact their learning experience and make it to where they're able to learn, that they choose to learn, that they have this belief that their time spent is worthwhile, so they'll take more information in. But if they don't, then maybe they might not have that same learning experience if they don't have this belief in themselves.
Right.
So we as researchers need to target not only their cognitive understanding, which that's important too, but also their emotions about their learning experience to help them have a complete learning experience, right? So that's something I try really hard to incorporate as an educator is on the first day of chemistry, organic chemistry class with my students, I ask them how they're feeling about the class, and I take time to tell them it will probably take work. A lot of things do, but this is something you are capable of, and I'm going to work to make sure that you have every opportunity to understand. So that's something that I really want to encourage educators who are listening or learners who are listening to take time to do, is to build up your student self-belief or your own self-belief, or, take time to attend to the emotions of yourself or your students as you're learning, because that matters.
Yeah. That makes complete sense. That is, yeah. That is, like, I never heard it put that way, but it makes sense. Like, I was just, as you were talking, thinking about the different classes that I felt very differently in, you know, that did determine how much I got out of the class, how much I understood it, how much I my feelings about it now, even they stuck with me, right? The way I feel toward those topics or subjects or whatever.
Yes.
It stuck with me. So that makes complete sense to me.
Yeah, it made sense to me too. And this leads really well into the research that I chose to do. So my area of expertise is organic chemistry. I love organic chemistry. I don't know if many people know this, but I did not do well the first time I took the class. But I had already enrolled in a lab where I was doing organic chemistry research, and that was so fun to me as an undergrad that I decided I wanted to study that in grad school, which is wild. And I kept going, and I actually had to retake the class. And not very many people know this. My students hear me talk about this a lot. The first time I got fine grades, but I knew that I wanted to do it long term and that I didn't really have a good understanding. Like I was getting good grades or good enough grades without really knowing what was going on. So I retook the course to try to do better. In that semester, I retook the course was the first time my mom had cancer. And so I didn't really learn anymore.
Yeah.
I learned a little bit more, but not a lot more.
Yeah.
And then I got to grad school and I had to take a sort of you can take like, I don't know if makeup course, what's the right word? It's as if you need a review or refresher course type of thing.
Huh.
There's a name for it, but I can't remember. Just to get you up to the baseline of you have a graduate level understanding, and then you can take your grad level courses.
Yeah. Sort of like a previously on.
Exactly. Previously in organic chemistry.
Yeah.
So I took one of those classes, but it was really fast paced. And so I was like, I still just don't know that I feel like I really get this. I feel I could learn a lot more about this topic. I don't feel that I have an expertise in organic chemistry, but I like the research. I really want to do this.
Yeah.
And so I volunteered to TA Organic Chemistry 1 for 2 different people in the same semester, meaning I spent hours every week in the class, taking notes, teaching students, answering questions, making answer keys. And that was the thing that finally got me to really understand it.
Nice. You just submerged yourself.
Yes.
And then it really...
And some students will go through once and have the understanding I had at the end of that, which is... Those people are so smart.
Yeah.
They don't know how much I admire them.
Yeah.
My students, I'm like, wow, you're smart. So.
Or it's just they're really lucky that all the things are lining up. The environment's working for them.
Yeah.
It's connecting to the 3 different things somehow.
Oh, yeah, that's true.
You know, something's working for them.
I'm helping to facilitate a meaningful learning experience as their educator. They don't have a lot of things distracting them. That's a different thing. Like there's a learning model where there's shades, sort of. It looks like shades, and only certain things can get through the shades to their brain that they can eventually process to long-term memory. And sometimes the shades are more closed than others.
Yeah.
Like if your mom's sick, maybe the shades are pretty down.
Yeah.
And if everything's good in life and, you're not doing anything else, the shades are wide open.
Yeah.
So... Yes, definitely. But that's also something to encourage you. If you like the work, it doesn't matter what grades you get. Just keep going. And I think I got a C the first time I took OChem too. And now I'm an expert. Now I have it.
Yeah.
So, if that's... sometimes my students will cry because they get bad grades. And I'm like, listen, if I can do it, so can you.
Yeah.
I believe in you. I'm here. I'll sit through OChem with you again if you want me to. So... anyway, so that's the area that I really like. And it took me a while to develop that expertise. So I've always been really interested in how students learn it.
Yeah.
And I love teaching it. And so I started when I switched over to chemistry education research, one thing that I noticed is students talked a lot about how organic chemistry was hard, and people talked a lot about how everyone hates it. So I wanted to know why people hate organic chemistry.
Yeah.
And then I was writing a paper where I was citing that students hate organic chemistry. And I was trying to find a citation for that because people talk about it in peer-reviewed journals in their introductions a lot, although there's not been a lot of articles that are actually about this. They'll just talk about why it's important to improve chemistry. And I was looking at all these people who had made that statement. I can think of like 3 off the top of my head, and I would try to find their citations, and there was none. There was no end of the line, right? There was no place that someone found that students hate organic chemistry.
It was assumed, it was understood by multiple people,
yes,
but had not been really
It's never been researched.
Right. It's been on their way to making a different point.
Yes.
They've said, hey, we all know this, right?
Yes.
And
so people will say, hey, we all know this. One person said that without a citation at all and was like, hey, we all know this.
Yeah.
So they hate it, and their drop, fail, withdrawal rates are really high. So people hate it, and they drop out, and let's fix the course. And then everybody else would just reference that statement, which was not
right.
not a study. It was just a statement,
right.
you know?
Or just referencing the rates, which doesn't tell you how people feel, but just tells you how often they drop out of the class or whatever.
Yes.
Like, doesn't give you other data.
Yes. So that was interesting to me, and I wanted to learn about that. And when I realized there was no end to the line, I thought, oh, well, I guess I kind of have to start with finding out how they feel, because we've been making these assumptions, and they do have really high levels of drop, failure, withdrawal out of organic chemistry. That is true. And I've seen a lot of students just anecdotally have to retake the course. I don't know how it is in other upper level chemistry courses, but that doesn't really tell us, like you said, how they're feeling. And it doesn't give us any insight into how their feeling is impacting their learning experience and vice versa.
Yeah, totally.
And that's something that we know. Learning is an emotional experience. So we need to know about those emotions, right?
Mm-hmm.
Something else that's interesting about organic chemistry before I get into my personal research is Dr. Nicole Growlich did a review of 15 years worth of organic chemistry education research. And one of the consistent findings that Dr. Growlich noted in her paper is that students can oftentimes get the right answer, but not be able to explain why.
Yeah.
And so even those students who aren't dropping out, based on some of the chemistry education research that's coming out, even those students who may be succeeding well might not have a good understanding still of the course. They just are relying on memorizing.
Totally. Yeah, that makes total sense. And a lot of people's, I'm sure the study tips that they got or whatever may have led them down that path too, where it is like, oh, you got to memorize it, you got to take the test and all that stuff. But it makes sense. It's so hard to explain it back as if you know it.
Yes.
And could teach it, you know?
Yes, it really is difficult. And so those two things together, and my own experience in being an OChem TA, made it pretty clear that there was something going on in this class, and I wanted to know about it. So based in this this idea of we're looking at their feelings and a really good construct within, I guess construct is kind of a complicated word, but a really good framework within a framework sort of is attitude.
Mm-hmm.
An attitude sort of addresses how students are feeling and what they're thinking and how they're behaving towards a topic. And so that was the thing that I picked to investigate students' feelings towards organic chemistry. I wanted to look at their attitudes really overall, not just how they felt, but also what they were thinking.
Got it.
But not how they're thinking about it cognitively, but their thoughts about it, if that makes sense.
Yes. And attitude is a feeling word more in more ways than it is like a...
Right. It's not a cognitive word.
Yeah.
It's not a thinking word necessarily. But this is a really good, there's a paper by Zhu and Lewis, and I can cite it in our references, but they say in the same way you think thoughts about ice cream, you also have feelings towards it. You may think it's really tasty, but it's not the best for my waistline or my blood sugar, but you may feel yay. And both of those sort of make up your attitude towards the thing, right?
Right.
The ice cream or the course. Like, oh, this is a good course for me to learn, but I'm not excited.
Yeah.
you know? Yeah. Those are both parts of an attitude towards something. So that's what I chose to look at. And so I asked students how they felt about learning organic chemistry, and then I asked them a series of questions about what they thought. And I did a pilot study, and the most interesting thing that happened in my pilot study that I love telling people about is we asked students how they felt about learning organic chemistry, and they responded with what they had heard about the course. And I was like, what is this?
Yeah.
This is such an interesting find. They don't answer necessarily how they felt. Very many students responded with what they had heard.
Yes. Dang.
It was amazing.
Crazy. It's crazy that's like a trend that happened often instead of just being like...
it was very noticeable.
Wow.
So, and it wasn't, why do you feel the way you do? It was just, how do you feel? And they would talk about what they had heard.
Yeah.
And so that made us expand the study to where we looked at not only what they felt, but why they felt the way they did. And that was beautiful. I learned so much, and it was so fun.
Dang.
So some of my big findings actually were, it seems like on-sequence students and on-sequence means like you start OChem 1 in the fall.
Okay.
And you start OChem 2 in the spring. And this is at our institution. So, you have to take that into consideration. But these students in the on-sequence where they're starting in the fall actually have a pretty good spread of attitudes.
Mm-hmm.
And then it seems like the off-sequence students may not have as positive attitudes based on the qualitative data and the quantitative data.
Got it.
Their emotional satisfaction may be a little bit lower in the off sequence, so them starting in the spring versus starting OChem 1 in the fall. But for the most part, their attitudes are all over the board. There are people who are positive, there are people who are negative, and there are people who are kind of neutral, and there's a mixture.
Yeah.
And the proportion that was positive and negative for the on-sequence course was actually pretty equivalent.
Okay.
And then there's a big chunk who are positive, and then they have a but, and then some kind of anxiety. I'm excited, but I'm nervous. I'm excited, but I've heard it's hard, so I'm scared. Yeah. I am interested, but I think it's going to be one of the harder classes. There's a lot of that.
Right.
And so my takeaway from that was I need to address that aspect of students who have the positive but are scared initially to help them have a more positive attitude towards the course and a more positive learning experience overall. So that was an interesting finding, is they don't actually hate OChem across the board like we thought.
Yeah.
But when we followed them over time, they kind of start to, which is kind of a bummer.
Yeah.
And that gives us a lot of insight into the course. So the course itself, when students talked about what made them feel that way, they talked about their educators and they talked about the course content itself. Some of them talked about their general chemistry experience, but something that I found was really interesting is they talked about how fast-paced it is and how it doesn't seem to apply to everyday life. One of my favorite quotes is, there's a reaction they have to learn called ozonolysis. And you've never heard about it on this podcast because it doesn't really come up.
Yeah.
And the student said, and I quote, "I will never need to know about ozonolysis or whatever else in everyday life."
Yeah.
And I thought that's kind of true.
Yeah.
Actually. And so it was really interesting to read how much they didn't connect. And I did a few interviews with students and I saw the same thing. And it was so hard not to be like, listen, but here's the thing. Have you heard about this podcast called Chemistry for Your Life?
Yeah.
But it was very interesting and also very sad to me. And they also talked about, because there was so much information, they relied on that memorizing. There's so much to learn and I'm just memorizing all this stuff. And so they have this perceived idea that the course is emphasizing memorizing when that's not really the goal.
Yeah.
So that gives us insight into, okay, this is how students are feeling about the course. And now, I don't know if it will be me because I'm kind of shifting gears, but someone should come along and take this information and then they can use this data-based, like this is evidence-based information about how students are feeling towards the course and make interventions based in that evidence to improve the course overall.
Totally. Yeah. It's one step still very, very valuable to have just gotten really good information about something.
Right.
And even if that's already a big project.
Yes.
Even if you don't know exactly.
It took me 3 years.
Yeah. Even if you don't know exactly how to solve it, or it'll take a lot of people trying to interpret the information into strategies or whatever. But it's so great that it is there now.
Yes. Now we sort of have a baseline. And obviously there's so much I would do differently at the end of my PhD than I would at the beginning because I've learned so much. I'm a different researcher now than I was back then.
Totally.
But this is still good information to have. And we got this information using an instrument that we know is accurate and precise. And we did an analysis process that's trustworthy. And so this is good information. And I hope that other people can take it and use it to make the course better. And it will take a long time. And we work in a system and you have to really think about, what can we cut out? Are we teaching them things that's going to help them for biochem? Are we not? I think there's some evidence that we're not really teaching them what's going to help them for their next class, and how can we individually as educators make a difference, but also how does the system needs to be changed and whose job is it to change the system?
Yeah.
So, and we've talked a lot about that in research, you and I, that it goes little by little and we learn new things. So there was the common idea that students hate organic chemistry. And my research shows that's not necessarily true.
Mm-hmm.
So now let's refine our idea and say maybe students don't hate organic chemistry when they start, but it seems like they're shifting negatively by the end. And what can we do about that? Right? And so we are taking in new information and we're changing our perspective and we're doing what we can with that to make this situation better. And that's always what science is you're taking a little bit more information that maybe you're building on previous people and you're building on previous research, and then you're going to be able to take the next step forward.
Totally. And the fact that, like, I was thinking about you being in a situation where you were reading different people's journal articles that reference the idea, the idea that was not yet proven or not really researched, that people all hate it. Now people coming along, reading similar things like that want to delve deeper. There actually is something they can look at. They could go look at what you've done.
Yes.
And start making that process. But it's funny because you were in that spot only a few years ago.
Yes.
Where there weren't other...
Yes, that's part of the goal is somebody asked me what the goal of the instrument that I created is, if I want people to keep using it. And actually, I don't really know that I would encourage people to use it in the form it's in right now. I think it needs a lot of revisions. But I do want people to ask those qualitative questions and get some of that data and see that maybe students don't have the attitudes that we think.
Yeah.
And I also want students to look at the data I got, or I want researchers, I guess, to look at the data I got and see, oh, maybe people don't dislike organic chemistry the way we thought.
Yeah.
Those are my two big goals, is to ask the question and to look at the data and know that it's not this ubiquitous hatred. There is a big reputation problem. There's not a ubiquitous hatred or fear of organic chemistry in our OChem 1 students.
Yeah.
And that's important.
Yeah.
That's what I want my research to show, is to get a baseline of the attitude and then to also have somewhere that we can maybe go from there.
Yeah. This is like so dumb, but I was reading a book today that referenced the really, kitschy phrase from the G.I. Joe toys and show that was like, now I know, and knowing's half the battle. Like they'd always teach some sort of lesson.
I've never heard of that before.
Okay.
No.
Knowing's half the battle is one of the catchphrases that came from that. I mean, they might have written that, but it was very famous as part of the G.I. Joe stuff. And it's funny because like that's basically what you just sort of did.
Yes.
There was a gap of knowledge that you filled in that was like, and now, but knowing's only half the problem. It's like, well, now there's more to come.
Yes. So now we filled in this gap, and now we need to start using this evidence, change in the classroom, and then use more instruments to measure how effective those changes in the classroom are. And then we need to spread that information around, which is even another step, right? So there's all these steps before much improvement can be made, but this is like, now we know.
Yeah.
So that's pretty much it. That's not really a chemistry lesson, but more a lesson in what other fields of chemistry there are.
Yeah, and a sort of overview of what Melissa's been up to that isn't the podcast for the past while that we've made lots of references to, but you have not had many details yet.
Yes.
Listener out there. And so now you got a little bit of a catch up on that, which is cool.
And if you want to ask questions, we will be doing a Q&R soon. So please send me your questions about my research. People have really good questions that make me think and get me excited. So I'd love to hear from y'all about that. And I think we're probably going to skip doing our week in review, but I do want to share some exciting news to wrap us up.
Okay, sweet.
Which is that I have accepted a postdoctoral research position to continue doing chemistry education research, although it will be in a different area, with Dr. Allison Flynn at the University of Ottawa.
Nice.
And don't get scared. The podcast is still going to happen. Jam and I will still be actually able to record in person because I'm predominantly remote at this position. I'll only be in Canada a few times. But I'm really, really excited. So I wanted to share with y'all that I'm shifting gears and I'll be starting a new project in September, and I'll be working with a new group of people, and it's really scary and also really exciting. And so if you see social media that I'm in Canada, that's what's up.
Yeah. So. Dang, that's awesome. Congrats on all of that stuff, on everything, on the PhD stuff, which I guess we said before, but also the accepting the postdoctoral position. And thanks for taking time now that you can to share all of your research and stuff with us.
Thanks for listening. And thanks to all of you who asked about my research. That was so kind. I love I loved getting those messages. And yes, please reach out and ask any questions because it makes me so happy to share.
And again, thank you for sharing it with us. If you, listener, have questions like usual about a chemistry lesson of everyday life, something, or a question about Melissa's research, please reach out to us on Gmail, Twitter, Instagram, or Facebook at Chem for Your Life. That's Chem, FOR, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the cost of making it, go to ko-fi.com/chem4yourlife or tap the link in our show notes to donate the cost of a cup of coffee. If you're not able to donate, you can still help us by subscribing on your favorite podcast app or rating and writing a review on Apple Podcasts. That also helps us to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and J.M. Robinson. References for this episode can be found in our show notes or on our website. J.M. Robinson is our producer, and we'd like to give a special thanks to S. Navarro and V. Garza, who reviewed this episode.